Hello, myself Mrunal Dattatreya Paritkar and my topic for the presentation is Hive. So let's begin with the introduction of Hive. Apache Hive is a data warehouse infrastructure built on top of Hadoop for providing data summarization, query and analysis. Hive provides an SQL dialect called Hive Query Language, HiveQL or HQL for querying data stored in a Hadoop cluster. SQL knowledge is widespread for a reason. It is an effective, reasonably intuitive model for organizing and using data. SQL is well known and it is widespread for people. Mapping these familiar data operations to the low-level MapReduce Java API can be daunting, even for experienced Java developers. Hive does this dirty job for you so that you can focus on query itself. Hive translates most queries to MapReduce jobs, thereby exploiting the scalability of Hadoop while presenting a familiar SQL abstraction. Hive is most suited for data warehouse applications where relatively static data is analyzed, fast response times are not required, and when the data is not changing rapidly. When the data is static, for example, the data which is already stored, which are in the tables, which are previously stored, that data is analyzed, and when the fast response time is not required and when the data is not changing, means the data is not dynamic, that time Hive is most suitable. Hive is not a full database. The design constraints and limitations of Hadoop and HDFS impose limits on what Hive can do. The biggest limitations is that Hive does not provide record level update, insert, nor delete. You can create new tables from queries or output query results to files. Also, because Hadoop is a batch-oriented system, Hive queries have higher latency due to startup overhead for MapReduce jobs. Queries that would finish in seconds for a traditional database take longer for Hive, even for relatively small data sets. Finally, Hive does not provide transactions. So let's see now HiveQL. HiveQL is a Hive query language. Like all SQL dialects in widespread use, it does not fully conform to any particular revision of the ANSI SQL standard. It is perhaps closest to MySQL dialect, but with significant differences. HiveQL is very similar to MySQL, but it is bit different, so it makes it differ. Hive adds extensions to provide better performance in the context of Hadoop and to integrate with custom extensions and even external programs. Now we'll see the data model. Hive structures data into well-understood database concepts, such as tables, rows, columns, and partitions, as we all know. It also supports the data types, for example, integer, floats, double, and strings. Hive also supports associative array with a pair of key type value type, that is map key type value type. Hive also supports list element type. Hive also supports struct file name and its file type. The next is SERDE. Serialized and deserialized API is used to move data in and out of the tables. Now we'll say the data storage. Tables are logical data units. Table metadata associates the data in the table to HDFS directories. Now we'll see the HDFS namespaces. They are tables, HDFS directory, partition, which is an HDFS directory, buckets in subdirectories within the partition. We can have HDFS directory as /user /hive /warehouse /test table is a HDFS directory. Now we'll see the architecture of Hive. So we have Hive with components as JDBC, ODBC, command line interface, web interface, thrift server, metastore, driver which has compiler, optimizer, and executor. The next we have Hadoop, which is a combination of MapReduce plus HDFS, Hadoop distributed file systems. The next we have job tracker, name node, data node plus task tracker. Now we'll see the components of it. First is a metastore. It stores the system catalog. Then we'll see this in detail. The next one is a device driver. Manages life cycle of Hive QL query as it moves through Hive. Also manages the session handle and session statistics. The next is query compiler. Compiles Hive QL into a directed acyclic graph of MapReduce tasks. The next is execution engine. The component executes the task in proper dependency order, interacts with Hadoop. The next is a Hive server. It provides the thrift interface and JDBC ODBC for integrating other applications. The next one is a client components, CLI, web interface, JDBC ODBC interface. The next is extensibility interface include SERDI, user-defined functions and user-defined aggregate functions. Now we'll see the main components, that is metastore and SERDI. Hive stores the schema of Hive tables in a Hive metastore. Metastore is used to hold all the information about the tables and the partitions that are in the warehouse. By default, the metastore is run in the same process as the Hive service, and the default metastore is Derby database. The next we'll see is SERDI. Serialize, deserialize gives instruction to the Hive on how to proceed on a record. Now we'll see the Hive commands. The first ones are DDL commands, that are data definition language commands, which are used and which are responsible for defining and changing the structure of database or table in Hive. The DDL commands are create, drop, truncate, alter, show and describe. These are processed on database or table. The next we'll see the DML commands, that are they are used for inserting and querying the data from Hive tables. They are load and insert. The syntax for load is load data, local path, local in path, HDFS file path / local file path, overwrite into table existing table name. The next we'll see the installation of Hive on Linux. First we need to make sure that Hadoop is properly installed, it is configured and it is properly running. The first step is we need to download the Hive tar file, that is Apache Hive 1.2.1 bin.tar.gz. Then we need to extract the folder and rename it. Next we need to set up the variables for Hive in bash rc file. The next is update the Hive configuration file by hiveconfig.sh. Then the fifth step is we need to create a directory for Hive in HDFS by Hadoop fs make directory p /user/hive /warehouse. The next thing is update the permissions for it. Then the next step is we need to change the mode of that, Hadoop fs chmod g+w /user/hive /warehouse, or by using Hadoop fs chmod g+w /tmp. For running the Hive, we have a command Hive. This is the installation of the Hive on Hadoop. Thank you.